all we are doing, finding the resistance individual, then afterwards equivalent in series parallel. Generally, one sum is asked on this topic of resistance. Very simple because you all are knowing this topic. First one, factors on which resistance depends. So please solve all the questions which I send you and entire solution which I have sent you of electrostatics. And if you are not able to manage, I will tell you which sum you have to do and how you have to follow. Factors on which resistance depends. First one, resistance is directly proportional to length, correct na? Inversely proportional to area of cross section. It depends upon temperature. Fourth, it depends upon material. Now, therefore, R is rho L by A. So R equals proportional to L by A. So this is rho L by A, where rho is constant. What is this called as?
Specific resistance.
Or
Resistivity.
called as specific resistance or resistivity. Just copy till this. Called as specific resistance or
Done, sir.
hello? Hello, Tasmay? Hello, Tasmay? Tasmay? Yes, completed.
Yes, sir.
SI unit of specific resistance or resistivity is ohm meter. Reciprocal of resistivity is conductivity. Therefore, sigma equals to 1 upon, yeah, copy. Jennifer? Hello, Jennifer?
Yes, sir. Yes, sir.
It is that CBSE lecture I have posted. Could you go through it?
No, sir. I'll go through it today.
Yeah, because if doubt is there, you have to ask. Na?
Okay, sir.
If any doubt comes, just tell me when I can keep the lecture. If there is doubt, I will keep.
Yes, sir.
Suppose you go through it and something you don't understand. So tell, sir, I have doubt. I will then keep lecture for you. If not, then I will not keep. Okay. Yes, everybody has done till this.
Yes, sir.
Yes, sir.
Aniket, you are there?
Yes, sir.
तो बीच में आप लोग कोई तो निकल गया था. तस्मय, you are there ना? तस्मय?
Yes, sir. I got disconnected, sir.
No problem, beta. I'm just recording the things. If you get disconnected, you'll be able to see.
Okay.
Why I was telling, calling you. I have given you the solution. It is written heading explanation.
Yes, sir. I saw it yesterday.
Now what you will do, you all, not once, but you all, 1
Yeah.
to 25, you all will practice once again. And any
Okay,
doubt
sir.
comes, you will ask me.
Okay, okay, sir.
Today is what? Thursday. Tomorrow is Friday. I want to take lecture tomorrow. What time I can take? Can I take morning time? 8:30 to 9:30. Is everybody free?
Sir, we have bio. Oh no, we don't.
That means I can keep if I want.
Yes, sir.
Yeah.
Yes,
Other
sir.
other student, can I keep 8:30 to 9:30 tomorrow
Okay,
morning? Aryan, for you it is okay.
Yes, sir.
तस्मय, अनिकेत,
Yes, sir.
हाँ, बिकॉज क्या जितना लेक्चर ज्यादा होगा उतना अच्छा होगा, फिर बाद में हम लोग रिवीजन करेंगे. सो आपका आज का होमवर्क क्या है? ये 1 to 25, हार्डली इट विल टेक सम टाइम. यू ऑलरेडी हैव डन ना, ये सॉल्व करना वापस. डाउट होगा तो मैं इमीडिएटली कल क्लियर कर दूंगा. ठीक है?
Yes, sir.
हाँ.
Okay, sir.
तो नाउ यू नो कि क्या करना है. कंफ्यूजन मत करो. वो उसमें से 1 से 25 तक ऐसा 400 सम कर लिया ना आपने, तो आपका इलेक्ट्रोस्टैटिक परफेक्ट है. चलो. There is favorite question, wire is stretched वाला. When wire is stretched, बहुत बार बताया अनिकेत, आपको मालूम होगा 10th में भी बताया मैंने. When wire is stretched, अनिकेत, what is same? Volume, no? Hello?
Yes, sir.
Whenever wire is stretched, what is same? Volume is same, na?
Volume.
So can I say A1 L1 is A2 L2?
Yes, sir.
A means area, L means length, huh? So A1 upon A2 is L2 by L1. Now what is R? Rho L by A. Therefore R1 upon R2, can I say L1 upon L2 into A2 by A1? Hello?
Yes.
Yes, sir.
So in case both relation is given, area and length, we can use this formula. But generally, they will give only length or only area or only radius. So what I can do, if only length is given, when wire is stretched, then length, area I can replace for length. A2 upon A1, can I say L1 by L2? That means can I say L1 upon L2 ka square?
Yes, sir.
That is R is proportional to L square or not? When wire is stretched, see, when wire is stretched, don't say R proportional to L. R is proportional to what? L square. So if the error is less than 5%, then I will be using this formula. Like if they say length is increased by 2% by stretching, so I will say R will increase by power 2 into 2 4%. Derivative method बोलते हैं इसको. First chapter में. Hello?
Yes, sir.
But if they say length becomes double, then don't use this. Then use R1 upon R. Length is L1, new length is double. Double मतलब 4 times होएगा resistance. समझ में आया ये concept?
हाँ, sir.
Yes.
Yes, sir.
This you followed. When to use R1 upon R2, L1 upon L2 square, and when to use L proportional to L square.
Yes, sir.
If the increase is more than 5%, then this formula. Less than 5, then this shortcut wala. Okay.
Yes, sir.
Please copy now.
None, sir.
Yeah, no. Now, after getting length relation, we'll get find area and then radius. Mostly they ask one sum on resistance. ये नहीं पूछा तो कलर कोड का पूछेंगे, कलर कोड नहीं पूछा तो टेम्परेचर पूछेंगे. R1 upon R2. In place of L1 upon L2, I can write A2 by A1. Or R proportional to A raised to minus 2 because it is inverse. Yes, everybody has followed second also?
Yes, sir.
Aryan saying?
Yes, sir. Follow.
R1 upon R2, A2 का जगह पे pi R2 square upon pi R1 square raised to 2. So can I say it is R2 upon R1 raised to 4? This R2, R1 are radius. So R proportional to R raised to minus 2. So three formulas we got. R1 upon R2, L1 by L2 square, or A2 by A1 square, or R2 by R1 raised to 4 when wire is stretched. Please copy B and C concept.
Done. Done, sir.
अब एक सम बोलता हूँ, शॉर्टकट करना, मतलब एक लाइन में आंसर बता. A wire is of length L has resistance capital R. This wire is stretched to twice its original length. Find new resistance. एकदम जल्दी बताओ क्या आएगा, एकदम फास्ट चाहिए.
2R.
Pardon? How many are?
2R.
God, Jennifer.
4 hours, sir.
4 R आएगा ना. R1 upon R2 is L1 by L2 square, no? So R
Yes, sir.
upon
Sorry.
R, don't do this silly mistake here. Square, so it will become R2 is 4 times R ना. चलो प्लीज कॉपी. फिर अभी एक और देता हूँ, जब तक राइट नहीं आएगा ना सबका एक और दूंगा.
Done, sir.
A wire is stretched such that length is increased by 0.1%. So resistance will increase by what percent?
So 0.2.
Yes, 0.2, yes. This time R is proportional to use L square. So percentage increase in R is 2 times percentage increase in L. So 2 into 0.1, 0.2%. Written? Solution copied?
Yes, sir.
Now
Yes.
I'm changing this sum. Huh? A wire is stretched such that length is increased by 10%. Then what is percentage increase in resistance? Don't use this formula. Now write R1 by R2 is L1 by L2 square. What the answer? Yes, you got the answer?
Sir, 21%.
Correct, correct, 21%. R1 upon R2 is L1. L2 is 10% more. That means 110 upon 100 of L1 square. You can say. So this will be 10 upon 11 the whole square. That means 100 upon 121 is R1 by R2. Therefore, R2 is 121 upon 100 of R1. Therefore, percentage increase in R is 21%. है ना? Now everybody has followed this, when to use directly proportional to L square and when to use ratio of L1 L2 square.
Yes, sir.
Chalo, next. Shall I clear now? Tasmay?
Yes, sir.
I'm showing you one cube. There is one circle of 5. This is A, this is B length, and this is C. Faces are 1, 2, 3 4, ये 3 4, वैसे फ्रंट बैक 5 6. I want resistance across phase 1, 2 and across 3, 4. Try if you can. Rho is specific resistance. देखता हूं अभी किसको किसको जमेगा ये.
Sir, rho by
Rho by
A.
rho by A.
सर वो क्यूब का लेंथ A है ना?
नहीं, ये क्यूबॉइड है ना, सबका अलग दिया है, ABC दिया है ना.
अच्छा, ओके 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 सॉरी.
See, when you want between phase 1 and 2, तो 1 और 2 के बीच में करंट आके जाएगा ऐसा. So resistance between 1, 2 is rho. Length is always along the current. तो ये C लेंथ क्या हो जाएगा इसका? C होएगा ना. और एरिया इसका A भी, rho L by A. ओके. हेलो हेलो.
Yes.
Yes sir.
See, length means it is along the current. तो ये करंट ऊपर से नीचे आया मतलब ये वाला लेंथ हो गया, और उसको जो परपेंडिकुलर है ना वो एरिया होएगा. तो रेजिस्टेंस बिटवीन 1 and 2 is rho, length is C and area is this A into B. Everybody is cleared with this first one?
Yes.
Yes sir.
अभी 3 4 का बोलो, देखते हैं आपको जमा क्या. रो तो सेम है.
Rho B by AC.
वेरी गुड. रो बी बाई ए. तो ये डिफिकल्ट होगा तो ऐसा दे सकते हैं आपको. नेक्स्ट वन. This is for conductor which is in the form of hollow cylinder. We want its resistance. So this is one cylinder which is hollow. This is radius R1, outer is R2. इसमें मटेरियल है इतना, बीच में हॉलो है, ये मटेरियल है. We want resistance. So inner radius equals to R1, outer radius is R2, length is L, length L, resistivity is rho. Find what is current. Sorry, resistance. So resistance is rho L by A. करंट ऐसे जा रहा है, इधर से ऐसा एंटर हो रहा है करंट, इधर से निकलने वाला है. Then can you tell who is length? This part is length or this part is length? डॉटेड वाला लेंथ कौन है? लेंथ
So dotted.
डॉटेड वाला. एरिया क्या है मटेरियल का?
Pi R2 square minus सर
करेक्ट करेक्ट, वेरी गुड। तो हो गया रो एल, एरिया इज पाई आर टू स्क्वायर, जो मटेरियल है उसका एरिया ही है, बाकी तो ओपन है ना। दिस इज द रेजिस्टेंस, राइट। पाई यू कैन टेक कॉमन इफ यू वांट। So can I rub this now?
Yes, sir.
Same question, but current का direction I'm changing. This time current is not flowing like this, current is going in this manner. This way it is flowing. So from here to here will be length.
सर 2R2
No, first what will be area here? Area?
L into 2R2 सर।
देखो लेंथ तो इधर होता है ये,
क्योंकि वो हॉलो वाले को नहीं गिनेंगे ना,
नहीं
subtract
पहले
करना पड़ेगा।
पहले लेंथ इसके अक्रॉस में होगा ना, ये टोटल लेंथ,
Yes,
इतना
sir,
से
ठीक
करंट
है।
एंटर होगा ना, तो लेंथ अपना इधर से लेके इधर तक होगा। अभी वो भी ये तो हॉलो हो गया,
Yes, sir.
एंड एरिया ऑफ क्रॉस सेक्शन मींस जो ये परपेंडिकुलर पार्ट है ना, हेलो,
Yes, sir.
मतलब एरिया चेंज हो रहा है ना, एरिया वो कांस्टेंट थोड़ी है, इधर का एरिया अलग है ना, ये पार्ट का एरिया, फिर आगे का एरिया अलग है ना, फिर आगे का एरिया अलग है ना, तो ये लेंथ कांस्टेंट है इसका इधर से इधर, लेकिन जो एरिया है वो कांस्टेंट है क्या? वो तो वेरिएबल है ना, इधर सामने से देखो, इज द एरिया वेरिएबल? हेलो, हेलो,
सर वापस एक्सप्लेन कर दें।
तो बोलो थोड़ा अलग टाइप का करना। चलो, आपके हाथ में पेन है क्या या बुक है कुछ? तो
यस सर।
उसको अगर मैं सर्कल लेता हूँ, फोल्ड कर देता हूँ, तो सर्कल दिखेगा ना मुझे, सिलेंडर दिखेगा ना।
यस सर।
Yes, sir.
अब ये सिलेंडर से करंट इज फ्लोइंग थ्रू द बॉडी, मतलब ये आर पार जा रहा है बॉडी। तो व्हेन यू सी फ्रॉम द टॉप, ऑल द सर्कल्स आर ऑफ सेम रेडियस और डिफरेंट रेडियस। इनर वाले का रेडियस R1, आउटर वाले का रेडियस R2, अलग 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 है ना।
यस सर।
दैट मीन्स इफ आई कंसीडर एरिया ऑफ क्रॉस सेक्शन, तो टॉप वाले का एरिया ऑफ क्रॉस सेक्शन 2 पाई R1 होएगा, बराबर 2 पाई R2
Yes.
होएगा, और बॉटम वाले का 2 पाई R1 होगा ना। देखो आप सिलेंडर अपनी तरफ ले लो, पहले अपनी तरफ, तो गोल दिख रहा है आपको, गोल।
यस सर।
अभी वो सब गोल का रेडियस सेम है क्या?
नो सर, डिफरेंट।
डिफरेंट डिफरेंट है ना। तो पहला वाला 2 पाई R, दूसरा वाला 2 पाई R1, 2 पाई R2, ऐसा ऐसा बढ़ते जाएगा ना,
यस।
टिल एंड का कितना होगा?
R1 2 pi R1.
यस, तो करंट जो जा रहा है अपना फ्रॉम लेंथ वाला साइड एंड कमिंग आउट, तो उसका लेंथ तो खाली वो थिकनेस है ना अभी,
Yes.
अभी वो थिकनेस कांस्टेंट नहीं है ना, पहला वाला रेडियस 2 पाई आर एल, दूसरा वाला 2 पाई आर 2 एल, 2 पाई आर 3 एल, ऐसा होगा क्या? नहीं,
Yes sir.
नहीं समझ में आया होगा डायग्राम।
इंटीग्रेट करना पड़ेगा फिर।
यस, इंटीग्रेट वाला है, मतलब ये साइड को अगर करंट ऐसा एंटर हो रहा है सपोज इधर से लेके इधर तक, तो इधर जब ये एंटर हुआ तो ये पूरा 2 पाई आर और ये लेंथ, ये हो गया ना उसका बॉडी।
Yes, sir.
इधर जब ये एंटर हुआ तो ये वाला सर्कल इनर वाला, ये वाला हो गया ना उसका पूरा बॉडी, ये लेंथ हो गया ना, मतलब एरिया 2 पाई आर एल है ना, परपेंडिकुलर
Yes, sir.
एरिया ऑफ क्रॉस सेक्शन का आई एम टॉकिंग अबाउट। आर यू गेटिंग मी?
Yes sir.
सी करंट इधर से आया, इधर से अगर निकलेगा तो ये वाला पार्ट, ये जो है ना पूरा, ये लेंथ है। अब ये लेंथ मतलब कौन सा लेंथ? कर्व सरफेस एरिया पूरा लेंथ हुआ ना उसका। ये इसको मैं अगर ओपन करूं सिलेंडर को, तो ये उसका कट करके ऐसा होएगा ना पूरा ओपन, ये 2 पाई आर और ये एल ना। हेलो,
Yes sir.
इफ यू सी फ्रॉम फ्रंट तो ये सर्कल दिखेगा आउटर वाला, ये इनर वाला। इफ आई कंसीडर स्मॉल elemental part of dr, thickness dr, so area formula of the body is 2 pi rl, because this time current is not entering, ये एरिया थोड़ी लेना है अपने को ये बॉडी का एरिया लेना है, इसका एरिया ये पूरा है ना। it is curved surface area, correct or not?
Yes, sir.
So what is curved surface area? 2 pi rl.
Yes, sir.
Not understood? Again see.
Understood.
Pakka, everybody has understood?
Yes sir.
Yes, sir.
देखो जब भी हाँ सामने से एंटर हो रहा था तो हमको दिख रहा था क्लियर कट कि ये अपना ये एरिया, ये इतने एरिया में से जाएगा ना वो, ये पूरा हो गया था ना उसको परपेंडिकुलर, विच यू टोल्ड ये पाई आर 1 और ये पाई आर 2 स्क्वायर का डिफरेंस। लेकिन अभी तो ऐसा जाने वाला है, तो ये पूरा लेंथ कर्व सरफेस एरिया लेना पड़ेगा ना अपने को, एरिया ऑफ क्रॉस सेक्शन। नहीं समझ में आया?
समझा सर।
समझा, sir.
पक्का समझ गया आपको कॉन्सेप्ट? ये जो ये वाला पार्ट है ना वो पूरा एरिया का, और ये लेंथ हो गया ना ऐसा जाने वाला, जो ये इधर से जाके निकलेगा ये लेंथ हुआ, लेकिन एरिया तो ये पूरा होएगा ना ऐसा। थोड़ा डिफिकल्ट है टू एनालाइज, अगर कॉन्सेप्ट समझा तो फिर इतना डिफिकल्ट नहीं। तो ऐसा अभी एरिया क्या होएगा, इधर से एंटर हो रहा है तो इधर वाला एरिया ये पूरा कर्व सरफेस एरिया, करेक्ट? फिर थोड़ा कम थोड़ा कम थोड़ा कम, क्योंकि रेडियस कम कम हो रहा है, लेंथ कांस्टेंट है उसका, लेकिन एरिया में 2 पाई आर एल कांस्टेंट है, आर तो वेरी हो रहा है ना।
Yes, sir.
अब सब ये समझा बराबर? अभी क्या अभी भी डाउट है?
समझा सर।
So if I consider the cross sectional part, so this is my circle which outer radius inner r1, outer r2. If I consider a small element whose radius is thickness is dr, now I know area formula through which current is entering is curved surface area. So if I consider resistance of elemental cylinder whose thickness is dr, so resistance of elemental cylinder, suppose it is dr, rho is same, its distance through which it is moving is dr, and area is 2 pi into rl at that instant, मतलब कोई तो एक इंस्टेंट पे रेडियस r, ये थिकनेस dr, तो अपना करंट ऐसा एंटर हो रहा है ना, तो अलोंग द लेंथ जो होता है ना, अलोंग द करंट वो लेंथ होता है, तो ये लेंथ हो गया बराबर। इधर से करंट एंटर हुआ, तो इमेजिन करो अगर ऐसा एंटर हो रहा है ऐसा, तो ये जो थिकनेस है ये बीच वाला वही उसका लेंथ हुआ ना,
Yes, sir.
ये जो थिकनेस मैंने कंसीडर किया वो लेंथ होगा ना उसका थ्रू आउट, है ना।
यस सर।
तो रो हो गया उसका रेजिस्टिविटी, dr इज द लेंथ थ्रू विच इट इज मूविंग, एंड एरिया इज कर्व सरफेस एरिया पूरा 2 पाई आर एल। ऐसा जाता तो ये लेंथ होता l और ये एरिया ऑफ क्रॉस सेक्शन होता। अब ये वाला एरिया ऑफ क्रॉस सेक्शन है विच इज कर्व सरफेस एरिया, नॉट फॉलोड। यस जेनिफर,
Followed, sir.
everybody is followed, जेनिफर।
Yes, sir.
Which part we take length? Along the current, है ना। Length is always
Yes.
along the current. So current is going like this, so length will be ये छोटा सा part ना ये, for that elemental resistance. So I took that as dr. ये dr इधर आया तो ऐसा हो गया ना dr, है ना। अच्छा clear? 3D
Yes,
view.
sir. Yes, sir.
So in this case, that length is constant. dr is thickness which is changing from inner to outer. So I am using now integration. So dr is elemental radius, which is rho into elemental area dr into curved surface area 2 pi r l. Rho L length is dr, area is 2 pi r l. So can I say net resistance will be addition of all dr, 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 dr. So it is integration of dr from r1 to r2 variable. So that will become rho dr 2 pi rl from r1 to r2. Rho constant, 2 pi l constant, dr upon r is that variable term r1 to r. What is integration of 1 upon x?
Log X.
Log x. So this will be log of r from r1 to r2. So finally it will become log r2 minus r1 in the bracket.
Yes, sir.
That is same as log of r2 upon r1.
Yes, sir.
Yes, once again. See. This is cylinder. Having inner radius r1 and outer radius is r2. This is length L. We want resistance. Current is entering like this. So here length is curved surface area, which is not constant, and thickness is dr. dr means any distance dr. ये thickness dr. So we know that area, that is curved surface area, curved surface area is 2 pi rl. So resistance of elemental cylinder means very small cylinder whose thickness is dr, length is l, will become rho, area is, length is dr, that is thickness, and area is curved surface area 2 pi rl. Net resistance is integration of rho dr upon 2 pi rl from r1 to r2. Rho upon 2 pi l constant, dr upon r from r1 to r2. So rho upon 2 pi l, this is log of r from r1 to r. Then I think last line you understood. That will be log of r2 minus log of r1. Please copy till this. Then 2 more lines I am doing.
Done, sir.
Finally, you will get rho upon 2 pi L log of R2 minus log of R1. That is rho upon 2 pi L log of R2 upon R. Done?
Yes, sir.
Temperature dependence of resistance in metal. Okay. In case of metal, when you heat, they will expand or contract.
Expand.
Expand. So if length is increasing, resistance will increase.
Yes, sir.
So if I take R0 and RT, R0 RT be resistance at 0 degrees Celsius and T degrees Celsius, then definitely RT is greater than R0.
Yes, sir.
So can I say this is nothing but increase in resistance, that difference?
Yes, sir.
Yeah, experimentally it is found that increase in resistance RT minus R0 is directly proportional to first original resistance R0, second increase in temperature delta T. That means more the starting resistance, more will be the increase. Same way it depends upon increase in temperature delta T. Let R0 RT be the resistance at T degree Celsius and T degree Celsius. Or RT minus R0 is increase. Experimentally it is found that increase in resistance RT minus R0 is directly proportional to first original resistance R0, second increase in temperature delta T. Please write this much.
Done, sir.
Yeah, 1 minute. Huh? So we can say RT minus R0 is directly proportional to R0 and delta T. Therefore, RT minus R0 equals to alpha R0 delta T. Alpha is constant called as temperature coefficient of resistance. Therefore, RT minus R0, that I am taking R0 on left side, plus alpha R0 delta T. So RT equals to R0, 1 plus alpha delta T. This is temperature dependence of resistance. Copy further till last line. This is temperature dependence of resistance.
Done, sir.
So since RT minus R0 is alpha R0 delta T, I can also write alpha is RT minus R0 upon R0 delta T. So alpha equals to change in resistance. We can write as dr upon R0 into dt. So sometimes we can use this formula to get alpha, sometimes this if R is function of temperature upon dt. Write alpha formula, write down RT minus R0 upon R0 is a delta T, or 1 upon R0 dr upon dt.
Done.
Note, write down for conductors alpha is positive. For semiconductors alpha is negative. For alloys alpha is approximately 0. That means there is no change in the value of resistance by changing the temperature.
Done, sir.
एक छोटा सा कलर कोड बता देता हूँ. Color code method to determine value of resistance. In color code method, there are 4 bands marked on the resistance. 4 bands. 1, 2, 3, 4. First 2 band represents significant digit. Third is multiplier of 10 raised to n. And last is tolerance. So first 2 represents digit, third represents integral power of 10, and last represents tolerance, which is plus or minus either 5% or 10% or 20% for gold, silver, and no color. So different color codes are B, B Raw of Great Britain had very good wife. So code for this is black color. What I told here, B Roy of Great Britain had very good wife. ऐसे याद करना है. Very good wife. Black stands for 0, brown for 1, red 2, orange 3, yellow 4, green, blue, violet, gray, white. 5, 6, 7, 8, 9. If it is black color as the third band, then 10 raised to 0 multiplier, 10 raised to 1, 10 raised to 2, 10 raised to 3, 10 raised to 4, 10 raised to 5, 10 raised to 6, 7, 8, and 9. Understood this multiplier factors? Hello?
Yes, sir.
Just make this code and color and write the codings 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I'm giving you one example. B Roy of Great Britain had very good wife.
Done, sir.
Everybody is done?
Yes.
Yes, sir.
Yes, sir.
With tolerance के लिए 3 coding extra. Gold means plus or minus 5%. Silver plus or minus 10%. No color is plus or minus 20%. So if a carbon resistor has 4 colors, red, black, orange, gold, determine value of resistance. Red stands for digit 2, black stands for that code 0, orange stands for code 3, gold stands for tolerance plus or minus 5%. So can I say value of resistance will be 20 into 10 raised to 3 ohm plus or minus 5%.
Yes, sir.
Yes, sir.
Sometimes they will say 10 raised to 3 as kilo ohm. Clear? Hello?
Yes.
Yeah, solve. Homework is 1 to 25, that MCQ of electrostatics you have to do and revise and keep this ready so that if I solve numerical, you are not wondering formula part. And tomorrow lecture 8:30 to 9:30 for you. This is extra. And evening will be test.
Done.
Till end you have completed.
Yes, sir.
So that's all for today. Tomorrow we'll meet at morning 8:30 to 9:30. And complete that homework 25 numerical of electrostatics.
Sir, from the PDF which you gave.
Yes, from the video.
Okay.
That's all for today.
Thank you, sir.
Thank you, sir.
Thank you.
Bye, sir. Thank you,
Bye.
sir.
Bye. Thank you.